Now let's run arithmetic operations on scalar, vector, matrix, and tensor. Let's run arithmetic operations on scalar first. So let's declare two scalar A equal to, let's say, 100, and scalar B and assign 200 here. Then do the arithmetic operations, the basic arithmetic operations. And we can do the arithmetic operations either using the arithmetic operators or using the TensorFlow's arithmetic functions. Let's try using the arithmetic operators first. So we can say scalar A plus scalar B. And we can see the output. We can do the same thing using the add method of TensorFlow. So we can say tf.add and pass two scalars, scalar A and scalar B. And we can see the output here. And we know if we use TensorFlow's print method, then we will only see the output. So let's try that. Let's assign it in a variable, let's say result, and execute it and print it. tf.print result. Awesome. We can also run all other arithmetic operations. Let's try multiplication this time. Okay, not addition but multiplication. So scalar A into scalar B. And we can see the output. And we can do the same thing using the multiply method of TensorFlow. So we can say tf.multiply and pass scalar A and scalar B. And we can see the output. Perfect. Now let's create a vector and do some arithmetic operations. So vector A equal to tf.arrange, and we can say 10 here. Okay, my bad, it will not be arrange but it will be range. So we can say tf.range and check the vector. And we can see a vector with 10 values. Now let's create another vector. Vector B equal to tf.range. Let's start from 20 and go up to 30. And check the vector. And we can see there are 10 values. So we can see the both vectors shape and size are same. Now let's try adding two vectors. First, let's try using arithmetic operator. So we can say vector A plus vector B and execute it. And we can see the output. And for your better understanding, you can try adding these values manually. Like 0 plus 20 is 20, 1 plus 21 is 22, 2 plus 22 is 24, and in the same way, 9 plus 29 is equal to 38. Let's try using the add method of TensorFlow. Vector A plus vector B. And we can see the same output. What about multiplying? Let's try first using the arithmetic operator. Vector A multiplied by vector B. And we can see the output here. Let's try using the multiply method of TensorFlow. So tf.multiply and vector A and vector B. Sorry, my bad. It will be vector B. And we can see the same output. So let's create two matrices. Let's name those matrix A and matrix B. Matrix A, and create the matrix using the uniform distribution of TensorFlow's random module. We can say tf.random.uniform. Okay, let's try using normal distribution, not uniform distribution. So normal, and pass the mean, let's say 50, and deviation, let's say 5, and at the first param we have to actually pass the shape. Let's say we want 2 by 3. In the same way, let's create another matrix, name it matrix B. Shape will be same, and the mean, let's say 100, and deviation, let's say 15, and execute it, and try to add these two matrices using the arithmetic operator. So matrix A plus matrix B, and execute it, and we can see it has added. Okay, if you doubt, then you can check those manually first. There are two matrices, and you can add those values manually. Like we added and multiplied scalar and vector using the add and multiply method of TensorFlow, we can do the same thing here for matrix. So copy this and call the add method of TensorFlow and pass this and execute it. And we can see the result. Let's try multiplying this time. Awesome. What about one tensor? So let's create one tensor. Let's name it tensor A, and we will use the normal distribution. So tf.random.normal. Let's pass the shape 2 by 3 by 4, and then mean is, let's say 150, and deviation is, let's say 20. Copy this, name it tensor B. Let's keep the shape same, change the mean, make it 250, and the deviation, let's make it 30. Execute it and add these two tensors. Tensor A plus tensor B. Awesome. Okay, at this point we could understand that we can run any kind of arithmetic operations on any kind of tensors, matrix, vectors, and scalar in TensorFlow. Now let's try one more thing. Let's create two vectors with different shapes. So we can simply say tf.range and 10 value here, x, copy, and let's say 20 value here, y, execute it, check this x and y. We can see there are 10 and 20 values, and the shape 10 and 20, And now let's try adding these two vectors using the arithmetic operator first. X plus y. And we can see there is an error. And it's saying incompatible shapes 10 versus 20. Let's try using the add method of TensorFlow. tf.add and x and y. And we're getting the same error. And now let's create two matrices with different shapes. We can again say x equal to tf.random.normal and the shape 2 by 3, mean 50, deviation 10. Copy this. Variable y, shape is 2 by 4 and keep as it is. Execute it and run the arithmetic operation. And we're getting the same error. So now we could understand if we want to run some arithmetic operations on some matrix or tensor or scalar or vector, the shape and size must be same. Okay, now let's learn about aggregations and about a few math functions. First of all, let's try getting the minimum value of a tensor. So let's copy these two, paste it here, change it, change the mean and deviation if we want, 15, execute it. And now let's try to get the minimum. Okay, before that, let's check the value of x. Okay, if we look at the tensor, then we can see the minimum value it holds is 35. Now let's try to get the minimum using the reduce min method. So we can say tf dot reduce min and pass the x, the tensor. Okay, my bad. Instead of getting minimum, I'm getting the average. So not mean, but minimum, min. And we can see we're getting 35.04, the exact same value. What about the maximum value? We can do that using the reduce max method. tf dot reduce max and the tensor, and we can see it's 58.98. And this one. We can also get the mean or average of a tensor using the min method. So we can say tf dot reduce min and pass the tensor, and we can see the mean or average. We can also get the deviation, which also we have learned in lecture 5. So we can say tf. Okay, one thing to add, that standard deviation is not available in the core library. It's available in the math library. So tf.math dot reduce standard deviation, and we can pass the tensor and check it. Awesome. What about the sum? The sum of a tensor? Yes, we can get that. tf dot reduce sum and the tensor, and we can get the sum. What about the square value? The square value of the tensor, we can get it using the tf.square method. And we can see the square of all elements. What about square root? And we can get it. Well, we can see the values are fractions. But if we want, then we can get the round value using tf.round method and pass the tensor, and we will see the round value. If you are confused, then let's add one code cell, print x, and compare. We are getting the round value. We can also get the scale and floor of a tensor. Let's try that. tf.math.scale, and we can see all the element has sailed. Now let's try the flow method. tf.math.flow and the tensor, and we're getting the flow method. Now let's declare one vector using the range method. We can say tf.range and start from -10 till 20 and assign in a variable vector, check it, and we can see there are both negative and positive values. And using the ABS method, we can get absolute positive value. So let's try that. tf.abs and vector and print it. And we can see we are getting absolute positive value using the ABS method of TensorFlow.